I'm talking today for about 7 minutes on the use and validity of the formula triangle as a pedagogical method in physics and more widely in any mathematical teaching. The starting point of this is an example of its usage and importance, I suppose. The CGP revision guide. It is the best-selling revision guide on the market, and in every single revision guide that is aimed at the GCSE years, there is always a statement about how the most important skill is the use of the formula triangle. As on the back page here, it says physics formula, how to deal with them, and it describes that the method to use is the formula triangle. It's the same in all of CGP's revision guides. Now, in literature, there has been some peer-reviewed literature on this. In the School Science Review 2016, Ed Southall pointed out that the methodology of using the formula triangle was in fact an example of procedural teaching rather than conceptual teaching. And since Ofsted in the 2012 report in procedural teaching, the proliferation of teaching a method without the understanding of the method has been widely criticised. Ed Southall in the School Science Review points out that the formula triangle is such an example and should be, as a methodology, one of those things that we move away from. Now, I want to show you very quickly how we could model both with the formula triangle and without the formula triangle. This is something that I would need to do if the resources that the pupils are being given are telling them one particular methodology, and it is in literature being criticised as not the way to do it. Then as the teacher, it's important for me to model a correct way of doing it. And I've got a question here that I've just printed off from a past paper. I'm going to model the answer on the board just as I would if you were a pupil in front of me. So the question says, state the equation linking momentum, mass and velocity. So the equation, momentum equals mass times velocity, no problem there. But it's in the use of this formula that it gets a little bit more complicated. It starts off, a truck of mass 10,000 kilograms is moving with a velocity of 4.5 meters per second. A car of mass 1,500 kilograms has the same momentum as the truck. Calculate the velocity of the car. Now, as usual with physics problems, it's a wordy question with numbers throughout it. And in the modelling of this, I would say to my pupils, the very first thing we need to do is write down what numbers we have given and what they represent. So here, it's an interesting question because it's given us the information that we need to find the momentum of the truck. And then it's said that we then need to further process that to find out something about this car. So we have two different situations, which means that as I model this response, the first thing I need to write down is what I would call the variables. So what are the terms that are going to go into my equations? The very first thing is for the truck. This is the first situation. We have a mass of 10,000 kilograms. If this was not in kilograms at this stage, I would tell them to convert it. You convert all of your units into base units at this starting point. And it has a velocity of 4.5 meters per second. I am without calculator, excuse me. So this is the first situation. The second situation of the car is that it has a mass of 1,500 kilograms and it has the same momentum as the truck, and it wants to know the velocity of the car. Now, the key information here is that the momentum of the truck is going to be equal to the momentum of the car. Now, the stage through this is going to be that we need to work out the momentum of the truck, applying the formula, and then we need to use that momentum in the formula again, but with the missing variable as the velocity. So you can see here, this is going to require a rearrangement of the formula. So to start with, very easily, the momentum of the truck can be found, the momentum of the truck is just equal to 10,000 times 4.5. So well, that's going to be 45,000. And I'd always say check it on the calculator. Times 4.5 is 45,000. Indeed, just in case my mental arithmetic goes wrong. 45,000 units, kilograms, meters per second. This gives me another one of the variables that I need to process the next part of the question. That P over here now becomes 45,000 kilograms, meters per second. Now, normally, in an era where we were accepting the use of the formula triangle, my headers within the modelling of this solution would come out as variables, triangle, equation, working, answer, unit, and I would model this every single time, these steps, these stages. However, what I want to try to do is model here a way of doing it without the formula triangle. So I have got M and P. So what I could do is I could write that 45,000 is equal to 1,500 times by V. I would then explain at this stage that if I am multiplying V by 1,500, then I can undo that by dividing both sides by 1,500, thus explaining the algebra that the formula triangle would have done. So by dividing both sides by 1,500, I get V divided, I get, just to make sure we include all of the steps for clarity, I would end up with 1,500 times V divided by 1,500. Now this is a step that I could skip if it was a high ability set, but if I was being explicit about the instruction of the method that wasn't formula triangles, I would include this step to point out how this is going to cancel with this, leaving the formula 45,000 divided by 1,500 equal to V, which is basically this stage here. So we've processed what would have happened with the triangle and the equation together in this approach, and we've ended up with our working, which is this stage here. So V is equal to, and we just processed this, 45,000 divided by 1,500, and it's equal to 30. So it's 30 units, meters per second. But that's how we would do it. That's how we would model it if we were trying to show a different method to the formula triangle. And the main difference between it and using the formula triangle is if we use this space down here to go from this section again, how we would do it with the triangle is we would remember that in the triangle, P is at the top, M and V is at the bottom. Therefore, we're trying to solve this for V. So V would be P divided by M. P was 45,000 divided by M, which was 1,500, which is equal to 30 meters per second. Solved it without understanding what I was doing. And that is the problem. That if you do it with the triangle, you haven't taught them the algebra to understand how to actually rearrange. This method requires an extra step. It requires explaining for just a few minutes longer, but actually you have taught them how to go through this, not just procedurally, but understanding every step along the way.